And then now let's go into something a bit more complex. This problem in which I isolate y and get it by itself. So we've got y cubed minus xy equals -6. We're going to take the derivative of this with respect to the variable x. So since y is something that depends upon x, the derivative of that is going to be 3 times y times the derivative of what's inside with respect to x, so times dy dx, minus, now here we have a product of two functions, which requires us to use the product rule. And so I'll hold off on that for 1 second, and then I take the derivative of the right side, and that gives us 0. So in this case, I'm going to take the derivative of x with respect to x, which is just 1, keep the y, plus, keep the x, now times the derivative of the second piece, which is y, and the derivative of the second piece would be dy with respect to dx. So using a little bit of algebra here first, I'm going to distribute the negative sign. That's a place that's commonly, a place where students commonly make errors, is forgetting that that minus belongs to both of those quantities. And then as I did before, I'm going to get everything that doesn't have a dy dx over to the other side of the equal sign. So I have now 3y squared dy dx minus x dy dx is equal to y. And at this point in time, since I have dy dx in common between both of those terms, I'm going to factor out the dy dx. So I have dy dx, and what I have remaining is 3y squared minus x and on the other side I still have y. And so at this point, since I want to isolate dy dx, I can divide 3y squared minus x. And in this case, since you can clearly see, hopefully, that y isn't a function just of x, then its slope is going to depend on both our x and our y coordinates. Now, let's go back for just a second to our circle equation, x squared plus y squared equals 16. Technically, we can be taking the derivative with respect to anything, because x and y are dependent upon each other, as well as they could also be dependent upon other components as well. So if I wanted to, I could take the derivative of this with respect to y, so it would be 2x times the derivative of the variable inside with respect to y, plus 2y to the first times the derivative of the inside variable with respect to y, so dy dy, and that's going to be equal to 0 since the derivative is 16 at 0, and dy is just 1, so typically we don't write that. Now, frequently, x and y both depend upon another variable, typically the variable t. So if I wanted to, and this will be helpful for later on down the road, I could take the derivative of this function with respect to t. So it'd be the derivative of x squared, which would be 2x to the first times derivative of what's inside dx dt, plus 2y times dy dt equals 0.